All right, I'm going to go over a couple more examples of confidence intervals for a mean. So this says, ask young men to estimate their own degree of body muscle by choosing a set of 100 photos. Then ask them to choose what they believe women prefer. The researchers know the actual degree of muscle. For each of the photos, they can measure the difference between what a subject thinks and what women prefer. So it says a random sample of 25 young men had a mean muscle gap of 2.35 with a standard deviation of 2.5. So our sample size is 25. Our mean muscle gap is 2.35. Our standard deviation is 2.5. We're calculating a 95% confidence interval. So for degrees of freedom, to calculate our t-star value, we're going to do 25 minus 1, which is 24. And then we're going to look at our table. So 95% confidence level, we're looking at this middle column. And then we're looking at the 24 row. So 24 degrees of freedom, that's 2.064. So our t-star value is going to be 2.064. So now we need to check our conditions. So the first condition is the random condition. And in this case, it does say a random sample. So we would say random is stated. For the normal condition, there's a couple ways, right? We can look at our sample size and see if that's greater than 30. So 25 is not greater than 30. So then we need to see if the sample data is roughly normal. This says a graph of the sample data shows the data are roughly normal. So that's how that condition is met. So sample data roughly normal. Lastly, for the independent condition, we have to determine if our sample size is less than 10% of the total population. Well, in this case, our sample size is 25. That's reasonable to assume that that's less than 10% of the total population of men. So that's reasonable to assume, considering there's lots of men in the world. All right, now with calculations. To do our calculations, we're doing x bar plus or minus t star times the standard deviation, which is sigma over the square root of n, or in this case, since we're given the standard deviation as s, the sample standard deviation, this is going to be s over the square root of n. And we're just going to plug in what we know. Well, x bar is 2.35. So plus or minus t star, 2.064. Times our standard deviation, so 2.5 over the square root of n, 25. So this is our margin of error, and we put that in our calculator. 2.064 times 2.5 over the square root of 25, we get about 1.032. There's our margin of error. So to calculate our confidence interval, we're going to subtract that, and we're going to add that. So in that case, we get 1.318 as our lower bound and 3.382 as our upper bound. So now to interpret in context, we say we are 95% confident that the true mean size of the muscle gap for the population of all young men is between 1.3 1.318 and 3.382. All right, this next problem, we actually don't need to do much other than really just determine the correct t-star value. that's probably going to narrow down a lot of our answer choices. So in this case, it's clear that, see, notice I'm not even reading this problem because in looking at the answer choices, it looks like since they're all so different, we're going to be able to eliminate things based on where they fall in the formula. So the estimate is the same for all of them. 39, that's X bar, that checks out. Next thing we're going to do is we're going to look at the critical value here, and it looks like there's two different ones we see. We see 1.96 and we see 3.182. So in this problem, we need to determine what our critical value is. So in this problem, we have a random sample of 4 students, so n equals 4, and we're calculating a 95% confidence interval. So for degrees of freedom, we're using 3, and we're going to look at a 95% confidence level. So if we go to our table, 95% confident, and a degree of freedom of 3, it should be 3.182. So T star should be 3.182. Well, that means I can eliminate A, B, and D because those all use 1.96, which is the Z star value, which we use for proportion. So now we just need to determine if we're using this one or this one. Well, it looks like the only difference between the two is the first one we divide by the square root of 4, the second one we do not. This is our standard deviation, but in our formula we're looking for the standard deviation of X bar, which is should be S over the square root of n. In this case, it's going to be 8.83 over the square root of 4, which means that C is the correct option. All right, this problem we're going to have to do a little bit more calculation. We are going to have to calculate the margin of error. So margin of error is going to be T star times S over the square root of n, because this problem is about means. Well, they tell us a random sample of 9, which means n equals 9. And then we're calculating a 95% confidence interval. So first thing we're going to do is we're going to determine what our T star value is. So 95%, we're looking for degrees of freedom. In this case, it's going to be 9 minus 1, which is 8. So looking at the 8 row, it would be 2.306. So now I can calculate my margin of error. It's going to be 2.306 times the standard deviation, which is 6, over the square root of n, which is 9. So when we put that in our calculator, 2.306 times 6 over the square root of 9, we get 4.612, which means D is the correct answer.